Continuing on with Unit 2, which is all about equations. This video will be about learning target 2B, solving for a variable. By the end of this video, you will be able to solve for another variable in an equation and then evaluate it as well. Let's consider our first example. It says, consider the equation 10x plus 5y equals 80. In part A says to solve that equation, 10x plus 5y equals 80 for y. So this is similar to 2A because we're dealing with equations. The difference here is that we have two variables. We have the x and the y, but this problem is asking us to solve for the y. So our goal will be to isolate this y by getting everything else to the other side and getting the y by itself. So to do that, the first thing I have to do to get it out of the way is subtract the 10x from the left side, which means I have to do it to the right side. So on the left-hand side, I'm left with just 5y equals, now on the right-hand side, I have 80 minus the 10x. I can't combine these because these are not like terms. So in 2A, all of our answers came down to be single number. Instead, our answer is still going to be an equation. It will just, in this case, be y equals since we're solving for y in part A. Now the last thing we have to do to get y by itself will be to divide through by 5 to get the 5's to cancel. But whatever we do to one side, we have to do to the other equation to keep that equation balanced, which means I have to divide the entire right side through by 5. Now, we do want to be able to simplify this, and since I have two separate terms here, the 80 and the negative 10x, this is equivalent to saying I'm going to take 80 and divide it by 5, and then I'm also going to divide the 10x by 5. Once we break that apart into those two separate terms again, we can see that we can reduce this down even further, so our final answer will be y equals, and then 80 divided by 5 will reduce down to be 16, and then 10 divided by 5 reduces down to be 2. So we get minus 2x, and we were able to solve for y. We still had an equation, but that's okay. All we were asked to do was to isolate the y variable. Part B says, using your answer to part A, find y when x equals 3. So I already know what y is equal to in general. It's equal to 16 minus 2x. And they're saying, let's find the value for y. So my answer now should be numeric. I should get a number for y when x equals 3. So I'm going to go ahead and substitute in 3 for x, since that's the value they gave us for x. So we get y equals 16 minus 2 times 3. And of course, we do want to simplify that down to get our final value for y, which will be 16 minus 6. So our final answer then will be y equals 10. Let's look at example 2. So example 2 is similar. It says, consider the equation 7 times the quantity x minus 1 plus 12y equals 17. And part A is again having us solve that equation for y, and then part B will have us use our answers from part A. Why don't you guys pause the video and do part A on your own first right now, and then we'll check it together. Okay, let's go ahead and check our answer to part A. So our goal is to get this y isolated by itself. So I need to get rid of this 7 times x minus 1, and I'll have to worry about how to move the 12 and get the y by itself. The first thing I do want to do is distribute this 7 though, because my final answer I want as simplified as possible, so I don't want any parentheses in it unless they're absolutely necessary. Because I can distribute this 7, I'll end up getting 7x minus 7, because I have to distribute it to both terms, plus the 12y is still there, equals 17. From here, I want to move both the 7x and the 7 to the other side. I'm going to start by moving the 7 to the other side and adding 7 to both sides of the equation to keep this equation balanced. So we have 7x plus 12y is going to be equal to 24. Now I want to get rid of the 7x to the other side since I'm trying to isolate the y term, so I'll subtract 7x over. To get us more space, I'm going to write up here. We'll get 12y equals 24 minus 7x, or if you prefer, you could write it as negative 7x plus 24. Either of those will work. They are equivalent. The last thing we've got to do is divide through by 12 on the left side, so I just get left with y equals. What that means is I have to divide the entire equation on the right side by 12 as well, which is the same thing as dividing each part of this equation by 12. I can reduce down one of these, and 24 over 12 will be equal to 2, and then 7 over 12 does not reduce down any further, so I get negative 7 over 12 times x. And we have now isolated our y value. A couple things I do want to bring up on the side over here, just notation-wise. We could write the negative 7 over 12x like that, how we did in the equation. We could also write as negative 7 times x over 12. That would be equivalent as well. The x is still in the numerator here, so we just want to make sure in this first way we're treating the negative 7 over 12 as a coefficient, which will be helpful especially as we get onto later units throughout this course. But that is equivalent to the negative 7x all over 12, in case you guys are wondering. So these guys are the same. Okay, part B. Why don't you guys do part B on your own first, and then we'll check it together. So part B says, using our answer to part A, so I'm going to go ahead and rewrite what our answer for y was, which is y equals 2 minus 7 over 12 times x. We want to find y when x equals 2. So that means I'm going to substitute my 2 in for x. So I get y equals 2 minus 7 over 12 times 2. And I want to go ahead and simplify this. So I'm going to keep writing from here. There's a couple ways to simplify this. We could go 7 times 2 and get 14 over 12 and then reduce that fraction down. Or what I notice right away is technically this is 2 over 1, and I know that 2 over 12 would reduce down itself as 1 over 6, so I know that this will actually be equal to 7 over 6. But if you would prefer, I'm going to write it out on the side over here, you could first take the 7 over 12 times 2 and rewrite it as 14 over 12, and then reduce 14 over 12 down to 7 over 6, since both of those, 14 and 12, are both divisible by the number 2. But what I did right off the bat was see that, well, 2 can go into 12, so those guys cancel, and this would leave me with a 6 then, so I get 7 over 6. We're not done yet. We want to get to our final one fraction in this case, so to be able to add or subtract fractions together, we need a common denominator. And my common denominator here, my least common denominator, would be 6. Right now I have 2 over 1 minus 7 over 6. To be able to get a common denominator of 6, my second fraction is good, but the first fraction I need to manipulate so that I can get it to have a denominator of 6. So eventually I want it to be something over 6, but I can't just make it 2 over 6, that's changing the number. Instead, we have to multiply by what I call a fancy number 1, because number 1 is the only number I can multiply by that actually doesn't change anything. Now, why I'm going to call it fancy is because there's a lot of ways to write the number 1. So I could write it as 1. I could also write it as 2 over 2. That would be equal to 1. I could write it as 100 over 100. That would also be equal to the number 1. So in this case, because I need to multiply by 6 in the denominator, I'm going to multiply by 6 in the numerator as well, and 6 over 6 will be our fancy number 1 here, since 6 over 6 is equal to 1. When I do that, I end up getting 6 times 2 on top, or I get 12. Then minus 7 over 6 is not going to change, since I already had my common denominator there. From here, when we add or subtract fractions, now that we have a common denominator, my denominator will stay as 6, and I have 12 of them minus 7 of them, so I end up with 5 over 6 as my final answer then. Okay, example number 3. So example number 3 says solve 2x minus 3 over 4 plus y equals 4 for the variable y. So this looks a lot more complicated than what we started with on our first page, just because I already have this fraction here. I'm going to go ahead and rewrite this so that we can really look and see what's happening here. So I've got 2x minus 3 over 4 plus y equals 4. And my goal, remember, we're trying to solve for that y, so I want to get this y by itself. And I'm going to go ahead and highlight it just so we can keep track of it. So eventually I want something that says y equals. Well, right now my y is in the denominator, so the first thing I probably want to do is figure out how to get it out of the denominator. Well, we've had problems in other sections where if I wanted to get rid of something in the denominator, we multiplied by whatever our denominator was so that it would cancel out. So I'm going to multiply here by the entire denominator, which is 4 plus y. Oops, that one a little messy. Let me rewrite that. So 4 plus y. Now remember, whatever I do to one side, I have to do to the other. So I have to multiply the other side by 4 plus y as well. This is equivalent to 4 plus y over 1, and what that tells me then is the 4 plus y in the numerator can cancel with the 4 plus y in the denominator. And I'm allowed to do this because I'm doing it to both sides of the equation, so this is staying balanced. On the left-hand side, I'm just left with the 2x minus 3. Then on the right-hand side, we have 4 times 4 plus y. Now remember, our goal is to isolate this y. Right now it's inside parentheses, so I'm going to go ahead and distribute so that I don't have any parentheses. And I get 2x minus 3 equals 16 plus 4y. Now my goal from here is I want to, remember, isolate this y, so I have to figure out, well, what can I do with the 16 and what can I do with the 4? For the 16, I'm going to go ahead and subtract 16 to both sides to keep this equation balanced. So I end up getting 2x minus 19 now equals 4y. And the last thing I need to do is divide through by 4, so it cancels out on the right-hand side, but that means I also have to divide through by 4 on the entire left-hand side, which would be the same thing as going 2x over 4 minus 19 over 4. And if we can reduce any of these, we will want to, and 2 over 4 will reduce down to be 1/2. So I get 1/2 times x minus 19 over 4 equals y. And that will be our final answer for what y is equal to. Okay. Example 4 is kind of similar. So I'm going to have you guys pause the video and try example 4 on your own first, and then we can check it all together. Okay, let's check example 4. So it says solve 3 minus y over 2x plus 1 equals -2. Just like before, I'm going to go ahead and rewrite it just so I have it written a little bigger and I can work with this equation a little bit easier. Now our goal is to solve for y. So right now my y is in the numerator, so that's already taken care of. But the issue is it's being divided by this messy thing that says 2x plus 1. So just like in example 3, I'm going to go ahead and multiply both sides of this equation by that denominator so that I can get the denominator and my fraction to cancel out on the left-hand side. And as long as I do it to both sides of the equal sign, I'm okay, and we're keeping this equation balanced. So on the left-hand side, the 2x plus 1 cancels out, and we get left with 3 minus y equals, on the right-hand side, I'm going to go ahead and just distribute right away because I want to make sure my final answer is combined as much as possible. So we'll get -4x minus 2. The next thing we're thinking about is, well, how can I get rid of this 3? Well, I can subtract 3 from both sides, so I get left with -y. Remember, the negative sign hasn't gone away yet, just the 3 has, equals -4x minus 5 now, since I subtracted 3 from both sides. The last step I've got to do is get rid of that negative. Remember, that's technically a -1. That's our invisible -1 in front of there. So if I divide through by -1 on the left-hand side, that will cancel out and I'll just get left with y equals, but then I have to divide through by -1 on the right-hand side as well, which means I really have -4x over -1 minus 5 over -1. So my final answer then will be +4x plus 5, because dividing a negative by a negative will give us a positive number. Okay, here is our last example, and I'm going to have you guys pause the video again and try example 5 on your own. Okay, let's check example 5. So it says solve 3x plus 2 over 7 minus y equals 1. And again, we want to solve for y. So just like the prior two, I want to get that y by itself. So I'm going to go ahead and get rid of this fraction by multiplying through by 7 minus y. And whatever I do to one side, I got to remember to do to the other. So the 7 minus y's cancel then on the left-hand side. And we get left with 3x plus 2. On the right-hand side, technically I am distributing the 1, but multiplying by 1 doesn't change anything, so I still get 7 minus y. From here, I'm really close to getting y by itself. I'm going to go ahead and subtract 7 from both sides to move that over. And I'll end up getting, I can put it down here, 3x minus 5 equals negative y. The last thing I've got to do is again get rid of that invisible negative 1 in front. So if I divide through by a negative, I'll end up with negative 3x plus 5 equals positive y then, or just equals y. And there is our final answer for our last example. As you guys can see through these, they're similar to what we did in 2a. The difference now is we just have two variables and we're being asked to solve for one of those two variables, which means our final answer will still be an equation, and then that can be used to help us either evaluate it if we're given what the other variable is equal to. And this skill in 2b is just going to be extremely important as we move on and we talk about different types of functions in later units. We want to make sure we're able to isolate and move stuff around from one side of the equation to the other, even if I have two variables in play.